Welcome to The Explainer. Today, we're diving into a monumental shift in how artificial intelligence interacts with our critical infrastructure. Look, for a long time, giving AI the keys to the kingdom has felt a bit like, letting a teenager drive a bulldozer. It's an impressive prediction engine, absolutely capable of incredible feats, but it completely lacks the operational awareness you need in high-stakes environments. Enter SolveForce AI. We're going to look at how their architecture transforms AI from a blind guesser into a safe, context-aware digital helmsman powered by something truly revolutionary, a recursive corroboration loop. Let's get right into it.
So, picture this. It's 2 a.m. A legacy AI monitoring your enterprise infrastructure sees a minor lag and just autonomously fires off a command, restart the service. Sounds helpful, right? Well, except that service happens to be your core production database right in the middle of a massive global transaction batch. The AI just acted blindly, causing a multi-million-dollar outage in seconds. It knew exactly what the words restart the service meant syntactically, sure, but it had absolutely zero clue about the context, the dependencies, or the blast radius of what that actually meant in the real world.
And that's the core issue. Legacy AI relies entirely on statistical confidence scores. It optimizes locally, basically taking a swing just because it recognizes a pattern in its training data. But SolveForce AI? It operates in a completely different universe. It resolves multi-dimensional context. Rather than making some isolated guess, it coordinates across every single layer of the infrastructure stack before making a move. It's not just predicting the next likely token, it actually governs its actions based on true operational reality.
To understand how it pulls this off, we'll follow a clear journey through the system's engineering. We'll hit the AI pragmatics problem, meet the digital helmsman, map out the 5-pillar architecture, dive into the core reverse-forward corroboration loop, and finally, look at the governed learning gate.
Starting off with Section 1, the AI pragmatics problem. In linguistics, pragmatics is all about how context influences meaning. But in machine operations, it means an AI has to figure out exactly what a signal implies right here, right now, for this specific system. SolveForce handles this massive problem by mapping an 8-dimensional context graph before it ever takes an action. If a command says restart the service, it has to resolve the exact identity of who asked, the entity being targeted, the topology of dependencies, the time, domain, intent, and consequence. But take a close look at the authority node. The system absolutely must resolve who has the permission to approve, execute, or reverse this proposed action. If that authority isn't mathematically verified, the command goes nowhere. It's permanently locked. Moving on to Section 2, meet the digital helmsman.
The source architecture actually calls this the Kybernetes function, which is ancient Greek for a helmsman. It's super important to grasp that this AI doesn't just grab the wheel, close its eyes, and floor it. Think about a real helmsman on a ship. They check the map, physically turn the wheel, look back at the wake to verify the ship actually turned, and then they adjust the compass. That's exactly what the SolveForce AI is doing. It's continuously comparing the raw, observed state of your infrastructure against your strict, policy-governed rules, correcting its course in real time without guessing.
All right, Section 3, the 5-pillar architecture.
To really see what our digital helmsman is actually navigating through, let's follow the flow across the top of this unified intelligence architecture stack. Notice how it meticulously graduates from raw matter up through signal, language, meaning, action, and finally achieves coherence. This pragmatics layer, it doesn't just sit isolated in some cloud making theoretical guesses. It rests directly on top of and coordinates across your physical servers, your network structural syntaxes, and your semantic security definitions to unify meaning across the whole stack. Everything is fundamentally connected. Let's map out these 5 pillars from the ground up so we can really visualize this environment. Down at the base, we have signal. That's the raw physical voltage and measurable state of the hardware. Right above that, grammar defines the connectivity and permitted transmission paths. Then, syntax structures your network and cloud compute into actual working applications. Next up is semantics, where cybersecurity preserves identity, meaning, and trust. And finally, sitting at the absolute peak is pragmatics, the SolveForce AI layer. It's a perfect dependency chain, right? If the semantics layer says a user isn't trusted, the pragmatics layer inherently knows that governed action simply cannot proceed. Every single intelligent action relies completely on the physical and logical pillars beneath it.
Which brings us to Section 4, the reverse-forward corroboration loop.
Okay, this is the absolute core focus of our explainer today, and frankly, what looks to be the holy grail of safe AI, the recursive corroboration loop. The entire system is anchored by the bidirectional coherence axiom, which states
Everything sent forward must remain verifiable backward. Just think about how profound that is for a moment in the context of enterprise IT. Before this AI can act forward, it must be able to mathematically trace its own logic backward, down through the policy, the interpretation, all the way to the raw physical evidence on the server rack. If the physical server telemetry doesn't perfectly support the AI's pragmatic claim, the system immediately halts. It physically cannot guess.
Now, the formal white paper maps out a massive, highly complex 16-step recursive cycle for this loop, but we can distill this powerful engine into 4 macro phases to make it a bit easier to digest. First, observe and resolve. The system takes in the signal and locks down the definitive semantic meaning. Second, corroborate and calibrate. It independently checks telemetry to assess the true operational risk. Third, authorize and act, checking strict governance policies before executing anything. And fourth, and this is a real game changer, verify and learn. It measures the actual physical outcome against its own original prediction. It never just assumes an action worked just because it issued the command. It actually closes the loop.
So, what actually happens when that verified outcome doesn't match the initial prediction? Well, it doesn't just throw a generic error 404 or crash the whole system. It precisely decomposes the deviation into 7 distinct categories, and this is absolutely vital for true self-healing infrastructure. For instance, if a command fails because the AI simply misunderstood the human intent, well, that's logged as a pragmatic error. But if it fails because a backhoe just accidentally cut your primary fiber line outside the data center, that's a disturbance error. By categorizing the failure perfectly across state, measurement, semantic, pragmatic, policy, execution, or disturbance, the system routes the fix to the exact right engineering team or automated mechanism rather than just blindly guessing at a reboot.
And finally, Section 5, the governed learning gate.
Once an error is accurately classified, how does the system actually learn without accidentally corrupting its own rules? For anyone terrified of AI autonomously rewriting its own code, this is the ultimate safeguard. The architecture explicitly prohibits the AI from directly modifying core policies or runbooks based on a single anomaly. Instead, an anomalous result becomes a lesson candidate. That candidate then undergoes reverse causal reconstruction to figure out exactly why the failure occurred. Then, it requires independent validation, often from a completely decoupled human operator or an out-of-band monitor. Only after passing that strict gauntlet does it become an approved learning object capable of updating the system's codex. It is evolution, for sure, but it is completely governed evolution.
So we've seen how legacy AI acts blindly on localized statistical confidence, basically just crossing its fingers and hoping for the best. Meanwhile, the SolveForce digital Helmsman uses an 8-dimensional context graph, a unified 5-pillar architecture, and most importantly, a rigorous recursive corroboration loop to safely manage your most complex networks. It fundamentally ensures that every single action is verified backward before moving forward. So I'll leave you with this final thought. Is your infrastructure just reacting blindly to semantic triggers, or is it utilizing governed, contextual intelligence to actually learn and steer itself safely? Thanks for exploring this with me.